Okay, guys, good night. So today I will show you how to prepare this beautiful plot. As you can see, I will show you how to prepare both of this plot. So the left one is scatter plot with density contour, and the right plot is the Hexbin plot with density gradient. So the purpose of two of this plot is that we want to understand the relationship between two variables. So for here we have relationship between rainfall and temperature. So usually when we do mapping, we do relationship, we do pattern for one variable, right? But this time, this is how we see the relationship between two variables. For example, here we have Hexbin plot here. As you can see, the x value is temperature, y value is rainfall, and then we can see that most of the rainfall when it happened about 170 something like that, the temperature is about 26.5. So it occur more relationship is stronger here. So we can see when is the rainfall happen and when is usually the temperature of the rainfall. So we can understand the relationship between two variables. So I will show you the R code to prepare for this one. So let's see here. As we can see, let me put this one a little bit higher. Okay. 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 Now, first I will show you how to prepare scatter plot with density contour, which is this plot, the left one. So first we need three library we need to install, which is a ggplot2, dplayer, and reshape2. So you load this library first, and then you run. After you install this library, you run this library. If you don't know how to install this library, you can just put install.packages. For example, ggplot2. Okay, you put your cursor here, and then run line of selection, and then it will install the package for you. You see, now I'm installing the packages. You see, when the package is updated, when I'm installing it again, it will install. But usually it will not install anymore because I already have installed these packages. But I see that just now it's installing again because there is some update for this plot, for these packages. So I will keep it here. So this is the library. You need to install ggplot2, dplayer, and reshape2. So ggplot2 is used for creating the plot, and dplayer for data manipulation, and reshape2 is for reshaping the data. So run all of these three library. That is step one. You just load the library. Now we go to step two. We set the working directory and loading the data. So we set the working directory to the folder where your data files are stored, and then replace the path below with your actual working directory. So this is my working directory where I put my dataset. I put it in D drive, which is here. D research STI analysis. So I put my data here, here in this folder. So that is set working directory. Now I will load the temperature and rainfall dataset in CSV format. So I read this dataset CSV file, which is my temperature dataset and rainfall dataset. So it is in the form of CSV file because we want to run to see relationship between temperature and rainfall. So here I have my file, this one, PM era 5, TAG monthly white. PM era 5, this one. This is temperature. So this is the arrangement of the dataset. So as you can see, this is the arrangement of the data. So we have it's in the form of calendar format. So I have January until December from 1950 to 2022. And then we run rainfall also. So rainfall is arranged the same way. I arrange the data the same way. Because this is my input data. So it is in the form of the calendar format, in the white form, which is from January until December. It is monthly rainfall. Now we want to understand relationship between monthly temperature and monthly rainfall. Okay, we run this data. Okay, it's there. Now we reshape the data. We convert the dataset from wide format to long format for easier manipulation. Actually, my dataset is already looks like this. But if you already have in the long format, you can use the long format directly. So in wide format, each month is a column. In long format, months are row. So we use math function to reshape the data. So we use the math function here to reshape both of this data set just now. So we run this one. We can view the data. How does it look like right now by using the view function. Okay, for example, temperature after we melt the data, now it looks like this in the long format. If you want, it must be in the long format like this. That is the function of melting the data just now. That is for temperature, and we can see for rainfall, also it will look the same. Year, month, and rainfall. So this is the monthly rainfall. So this is after melting the data. Now we combine the data set. We merge the temperature and rainfall data set by the common column, which is year and month. So we have data set just now, we have year and month, right? Now we merge that data set. So this will create a single data set containing temperature and rainfall for each year and month pair. So we combine the data set by using the merge function, and then we combine the data set, and then we can view this data. We can view this data set. I like this view function. And then you can view that. You can see year, month, and then temperature and rainfall. So if you have the data set is already arranged like this, and then you can just skip all this part just now. But if you have this data set, you see, so you can see the month is not in a particular order, so it's okay. It doesn't matter, because what we want to see is how its relationship later on. So scatter plot with density contour. Now the last step, we want to plot that data. So create a scatter plot to visualize the relationship between temperature and rainfall. Then we add density contours to highlight area with high data density. So here we use a ggplot function. We use the combined math dataset just now. For x will be temperature, y-axis will be rainfall. So we use geom point, alpha value equal to 0.4. You can play around with this alpha value later on. And then the color of the scatter plot with the transparency, this is 0.4, color equal to blue. So geom density 2D color will be red. This is the density of the contour line, because there will be a contour, the density of that contour. You can play around, you can change the color here, but red is okay. So scale x continuous for average temperature. We put the label for x-axis as average temperature in degrees Celsius, and for y-axis, the label for y-axis will be monthly rainfall millimeter. And then I put the plot title. Title will be relationship between monthly rainfall and temperature from 1950 to 2022. And then the plot subtitle will be scatter plot with density contour. And then I put the caption as the data source will be era 5. And then we apply a clean and minimal theme to the plot. So Now we run all of this function for ggplot function, run all of it, and then we have this plot prepared very nicely with the right value, rainfall, and temperature. And this is the title, scatter plot with density contour. And the data source is era 5. So I'm using era 5 dataset. It's good to put your data source here is era 5. So you can see here, the contour line is red. And I put the alpha value is 0.4. Now let us look what happens if we change this alpha value to 1. Run step 5 again. Okay, now you can see that dot is become clearer, right? It's more sharp. But what happened when we use 0.4 just now? It's become more transparent. It's up to you, but this 0.4 more transparent is better because we want to see the contour. So what we can see here, most of the time, rainfall fall between in less than 200, close to 200 millimeter. That is what it means. And during that time, that most of rainfall happened during this time, from 1950 to 2022. Most of it happened here. And when it happened, temperature usually will be 26.5 degree. So we can understand the relationship is very strong. Usually rainfall normally will be throughout the year is maybe about 190 and the temperature will be 26.5. Now we understand the relationship between rainfall and temperature. And we can see some outlier here. Sometimes rainfall is very high and the temperature fall down to 25.5, something like that. Some extreme value is there, like this one. Very low rainfall. And what happens when there is low rainfall? Very low rainfall and temperature is very high. Because temperature very high, that is why it's very low rainfall. That is relationship between monthly rainfall and temperature by using scatter plot with density contour. Now we prepare a Hexbin plot. Now we want to prepare this plot on the right one. I like this, the right one plot, Hexbin plot. I like it better compared with scatter plot with density contour. It shows you the same information, but it's up to you which plot that you prefer. So to prepare Hexbin plot, the same thing, we load the library for ggplot2, dplayer, and reshape2. And then we set the working directory, we load the data. So set the working directory, which is D resource, where we put our data set, where we put rainfall and temperature data set. So we put our data set here just now. You can just copy this folder address and put it here. And make sure that there is 2 dash here. And then it will get your working directory. And then you load your temperature and rainfall dataset. So we have our temperature dataset is in the calendar format, and also rainfall dataset in the calendar format. And the same thing. So once we have that rainfall dataset, we convert that dataset from wide format to long format so that we can easily manipulate the dataset. So in wide format, each month is a column. In long format, months are row. So we use the math function here to reshape the data from wide to long format. So we run this math function. So now our data set will look like this. So we look at temperature. Yeah, it looks in the long format now. We just manipulate the data so that it's easy for us to make relationship between these two variables. So here, for example, now we look for rainfall. So this is for rainfall. You can see from 1950 to 2022. So now it's in the long format. Now we combine that data set, we merge that data set so that it will be only in one file. So we combine by using merge function. So we use our new data set, temperature data and rainfall data just now that we have prepared, and then we merge it. After we merge it, it will look just like I am showing you before. It will be in the single file. Year, month, average, and rainfall. But if you already have this kind of data set, you can directly use this data set in as your CSV file. Now we prepare the Hexbin plot. We create the Hexbin plot to visualize the relationship between temperature and rainfall. So this plot will aggregate the data into hexagons and colors, and it will colors them based on the density of point. So here we will use ggplot function. So we use our latest data set, which is combined melt just now, and our x-axis will be temperature and y-axis will be rainfall. So we use geom hex bin is equal to 3. So that's mean use hexagonal binning with 30 bins. We can play around with this bin later on. I will show you what different that it will make. And then we apply the color gradient for the density because we want to show if the density is high, the relationship is very strong. So certain temperature and rainfall, if its relationship is very strong for certain value, and the density will be very high. So we use option equal to C, so the name will be the density. And the x-axis label will be average temperature. We put the unit here in degrees Celsius, and the y-axis label will be monthly rainfall in millimeter. Now we use the plot title will be a relationship between monthly rainfall and temperature from 1950 to 2022, and the plot subtitle will be Hexbin plot with density gradient, and then we put the data source is from era 5, and then we apply a clean minimal theme to the plot. So this step 5 we can run. Now we have this Hexbin plot. Looks very nice. So it shows here the relationship of rainfall about 180 is very strong when temperature is about 26.5. So most of the rainfall is occur here, and the temperature usually will be 26.5. So it shows relationship between rainfall and temperature. Now let's see if we change the bin to 60. Let's see what will happen. So this is something that you can play around. Is the plot will become smaller here. You see, it's become smaller bin. So based on the judgment just now, 30 is okay. What happen if we put 10? Let's see if we put 10, the bins to 10. So it will become very big, but easy to for us to see the relationship if it's become too big, but less information. So it's better to go in between. The 30 binning is better. So it's easy for us to see more information, and relationship is easier to see between this monthly rainfall and average temperature. So if you have a study that you compare, want to understand the relationship between two variables, and then you can use this kind of plot for your result. It will be very, very nice. Okay, I think that's all for tonight. I show you how to prepare scatter plot with density contour and Hexbin plot with density gradient. Thank you for watching.